Howdy and welcome back. So thanks for hanging in there. We're almost done. So we're going to just run through or introduce a little bit more material, but through an example, which I hope will help reinforce it and allow you to see the utility of it. So additional material by example. So let's go ahead and just actually set up our kind of truck and fire truck classes. So if we go ahead and look here, we can see that a truck is going to have 1, 2, 3, 4 private data members. It'll have a weight in pounds, a fuel type, which would be in numeration class shown at the top center here, length in feet, and a length in height. We'll see that it will have a single parameterized constructor, which will take in initial values for those private data members, and then 3 behaviors: forward, stop, and reverse. Now looking over at fire truck, we can see here that it's going to extend truck. Its fire truck is going to be a truck. It will have a specialization as a one single data member, water capacity in gallons. And then we're going to have a parameterized constructor here, which will take in initial values for each of this truck's private data members, as well as an initial starting value for its private data member. And then we'll see here the behaviors that it kind of extends are going to be start siren and stop siren. So let's go ahead and run through this. So let's go ahead and say we're introducing a big red truck into our program. It's going to be of type fire truck. And to our parameterized constructor, we're passing in 36,000, fuel type of diesel, 52 for its length, 11 for its height, and then a water capacity of 500 gallons. Now the activation record for this object is going to be composed of a base component and a child component. The base component here is shown in yellow. The child component is shown in blue. So our big red truck of type fire truck has a base portion clearly shown in yellow, and then the derived portion shown in blue. The base class is going to be responsible, so truck is going to be responsible for maintaining the base portion. The child or derived type here, fire truck, is going to, its behaviors and functionality would be responsible for the child portion of this class. So the base component of big red truck was going to be constructed with truck's parameterized constructor, and the derived portion is going to be constructed using fire truck's parameterized constructor. So we could go ahead and define truck's parameterized constructor as having enough arguments for each of those, or enough parameters for each of those arguments. And then just in the initializer list, we can go ahead and say weight in pounds is going to get its corresponding our argument, and go through kind of the whole list of private data members. Now, when we go ahead and declare fire truck's parameterized constructor, we need to take in those values that we're going to ship off to the base portion. And where do we do that? In the initializer list, we call truck's parameterized constructor and pass to it the arguments that would be used to initialize the base portion of our big red truck object. And that would be weight in pounds, fuel type, length, and height. Those will be used to initialize when we go ahead and make the call to the parameterized constructor these data members. And notice because that constructor is scoped to truck, it has access to those private data members. And then, okay, we're not finished yet because we still have to build up the derived portion. Well, we can see here, we just, as we've done before, we simply set those values. So water capacity in gallons is going to receive the water value stored in the water capacity in gallons parameter. And at that point, we've built up our base portion as well as our derived portion of our big red truck object. So let's continue on here and take a look at, okay, we have our big red truck. Remember, a fire truck is a truck, which means we have access to its public interface. So our fire truck objects, in addition to The behaviors that we've defined to specialize our fire truck. Let me just use consistent coloring here. The start siren and stop siren. So these are two things that a fire truck can do, but a generic truck cannot. But in addition to those two behaviors, we also can do anything that a truck can do: forward, stop, and reverse. So notice here that we can ask the big red truck to move forward. This will call the inherited trucks forward. We could ask the big red truck to start its siren. Notice that when it's looking up these for start siren, it finds a definition within the inner scope or in the derived class. So it calls fire truck start siren. Then we call big red truck stop. Well, this is going to call the inherited truck stop because, again, we first checked the derived definition, so that inner scope, and then we didn't find stop behavior. So we checked the outer scope, which is the truck or the base class. And guess what? Lo and behold, we found it there, and we are going to therefore call the inherited truck stop. If we go ahead and stop the siren, again, same lookup process that'll resolve to fire truck stop siren because we found a definition there. So let's just add on a little bit to this. So given our big red truck, we can look at the big red truck through the lens of the base class. So what that means is we're only going to be looking at the base portion, which is going to mean we're only going to have access to the base's data as well as the base interface. So if we want to look at a derived class through the lens of the base class, so again, just focusing on the base portion of the big red truck, we can do this by taking a reference or a pointer of the base truck, base type truck to it. So notice here that if I have a reference to a truck and its name is big red truck base, that name is going to be bound to the base class portion of big red truck. And because if you look at the type here, that means it's only going to be able to perform those generic behaviors because we're looking at it as a base class object. We're not looking at it, in this case, through big red truck base as the derived object. The other way to kind of shift our focus and look at this object through the perspective of the base class would be to take a pointer of the base type. So if we go ahead and define pointer to big red truck base as a pointer to a truck object, and then initialize it with the address of big red truck, this pointer to big red truck base is only going to be focused on the truck portion of big red truck. And because it is of the base type, we're only going to have access to the public interface of the base type on our when we're accessing the base component of our big red truck through this pointer. And again, this makes sense. We're looking at it at this object through the perspective of the base type. So we'll see some of the how this you might be wondering at this point, well, how is this useful? We'll get into that in the next lesson, but you could think about storing a vector of pointers to trucks maybe. And kind of having some way to collect all our various types of trucks within one collection, but we'll get into that later. One thing I do want to point out is that when you do this, so truck, red truck, notice that this right here is creating a new object of type truck, and we're initializing it with big red truck. This is creating a brand new object. Here, we're just shifting our perspective on an existing object. Okay, so we're not like creating a new truck object. We're actually just looking at our derived class through the lens of the base type. Now here, no reference, no pointer, just truck, red truck, brand new object being created, and it's initialized with big truck. This will perform a member-wise copy of the base components of big red truck into the corresponding fields of the red truck object. And in that case, we say that object slicing occurs because red truck does not get any of the derived attributes that big red truck has because a truck object can't store those. So Why object slicing? Well, if big red truck has, say, fire truck portion and then truck portion, red truck is only going to have a truck portion. So member-wise copy of those fields, and we slice out that because we're unable to store that in red truck. So I was going to draw these out, but I'll go ahead and let you, think about this in perhaps a bit more detail. So on the left here, we have shifting our perspective, looking at a derived object, an object of the derived type through the lens of the base type. So in this case, looking at two different ways to look at a fire truck typed object as a truck. And then on the right, we have an example of object slicing. And I point out, hey, notice that initialization is occurring there. A brand new on the right there with object slicing, brand new objects being created. Now let's go ahead and look at, I guess, one last example here. I know it's been a long lesson, but we're almost done. This is the last slide. So given, say, a big red truck defined in main and the following functions. So pass by value, pass by reference. What are the implications of these calls? Well, if we're passing by value, notice here that a new object is being created. So we have object slicing. If we pass it by reference within this function, so we're passing big red truck to a reference to a truck object, within the scope of this function, we are looking at big red truck through the lens of the base type. Now go ahead and leave you all there. I mean, think about this, draw it out, maybe use some memory diagrams to confirm your understanding of this, but we'll see the implications of this more so when we get into the next lesson. So I hope this was productive. I hope these ideas associated with inheritance are clear at this point, and we'll get into polymorphism in the next lesson.